to major and small open source projects as much as I can. Well, not lately, because lately I've turned into a gardener, kind of into a hiatus, enjoying life and my newborn son. I've founded SKGTech.io, which is a local technology community in Thessaloniki, where I'm from, and also davidconf.org, which is a developer conference in Greece. You can find me at Twitter as Thanos. And let's get started about what we're going to talk today. The talk is in two parts. The first part is why logging is important and what we should do when we log. And the second part is about Logality, a library that I authored, and how it can help you scale your logging. And it has some new nice features. So why logging is important? There are basically 6 points why that logging is important. It helps us debug. It helps us trace the errors that are happening on local and most importantly on production. We can troubleshoot our performance, our application's performance. We can perform accounting, which is the act of knowing what user did what. And then we can have an audit trail if that is required, which is an immutable kind of accounting. And the difference is that it is immutable, and depending on the security requirements of our application, it can be more elaborate or not. We're going to see examples about that. And finally, security. So straightforward, having the log at the right place is going to save your bacon, and nothing more, nothing less to be said about that. We're going to explore a little bit later in the presentation how that can happen in the most effective way. And debugging and error tracing. So it is advisable to log a couple of things. First off, when the application is booting up, you should log the operating system, the user that is executing. We're talking about Node, so the Node runtime, and the Node environment, any other probably non-private environments, variables that you have that you might want to know while the application is booting, which are going to affect your application's behavior. And as your application is booting up and certain services, facilities, modules are starting to boot up as well, for instance, connecting to a database, connecting to a Redis data store, connecting to whatever. So each step of this way, you should log that, this is happening, this has happened. So at any point that your application might crash, you should know at what point it crashed exactly, right? So for instance, it crashed right after trying to connect to Redis. So that's where we're going to look for the problem. For every Node.js application, you should have your global error handlers, like the SIGINT or uncaught exception, and most lately the promise uncaught rejection global event handlers. That's also a very nice place to have your logs. If it is a web application and you're using Express or any other library, Koa, whatever, there is an HTTP error handler. That's also a very nice place to have a log there. And as we are transitioning into more of an async await pattern, there are naturally more error catch statements in your code, throughout your code. So that is a very good place also to have logs. So in each basically error handler, in each, wherever you handle errors, you should have a log as well. Performance. Logging isn't really about performance, but you could do it in a do-it-yourself manner. So for instance, you will have a log at the beginning of an operation and at the end, and you could check out manually in a do-it-yourself manner, the timestamp of when the operation started and the timestamp of when it ended. And that can give you an empirical sense as to whether this is now taking longer or not. You can be more elaborate about it. You can actually measure the time and log the time that it took. But generally, logging is not exactly the right tool for performance. However, you can use it when you need to as a quick way to understand how your application behaves. Now, let's talk a little bit about accounting, audit, and security. I'm going to group all of them together. So what we should log towards that end. For instance, we should log all mutating operations, anything that writes or updates to the database. You know, a profile is updated, an order is put, and that log becomes an audit trail when the data store is immutable. And I'm not going to dive more into that. It's a little bit out of scope, but you understand, I believe, what I'm trying to say. And in more secure applications, you might be also required to create audit trails on querying as well. So for instance, this user requested this information about the other user. Okay, this user fetched this document at that time. That might be important for your case. So you're going to need to log it as well. Flags are really important. Flags are essentially booleans. So you could have an audit or a security boolean, and essentially what you're doing is you are tagging your messages so you can easily query for them later on. And we're gonna talk a little bit more later about how you can do that. Now, be cautious for all of your logs, especially in the accounting, audit, and security kind of logs, because there are many personal identifiable informations here, right? So if you're going to store about behavior of a user, make sure that you tokenize the data so you don't leak personal information into your log, because the logs are probably going to travel into a third party. They're going to be stored into a different data store that might not be as secure as your database. And you might not have the exact same control on the retention. So try to tokenize the data when it comes to, you know, emails, user ID instead. Okay, something like that. So what and how to log. And these are 5 points that I recommend. We've already gone through, you know, what is important. Let's see how we can do that, how we can log properly. And this is basically the anatomy of what a correct logger should do in conjunction with what you should also be logging. And let's start with how to log. It's pretty straightforward. You're gonna need to pretty print for local development. That means that, you know, this is a pretty print log where it is basically human readable. You can read it as a human. You can see the timestamp clearly. You can see it's a notice, what file, what module triggered the log, and the log message. And then for production, it is recommended that you log as a JSON object. Okay, so its log message should be a JSON so that it is easily parsable and queryable by your log processing service. And again, we're not going to talk about what that might be. It's a little bit out of scope for this discussion, but you know, there are multiple solutions, either custom build or services like Logality that you can that they can consume JSON log messages. And it's also recommended that when you're doing testing, that you mute logging and there is no logging while testing. Who am I? So I have a log message. It is important to understand where this message came from. So this is what the who am I answers for you, right? So what is my runtime? You know, am I running on Node.js? Am I running on what? And what is my host name? What's my process ID? What is my process name? This information might sound trivial, but it is important, especially when you're dealing with multiple services and all of the logs are aggregated into a single service. This is going to be useful, and this is also going to be very handy for identifying what log came from when you're trying to backtrace logs weeks ago, right? Now, the next question that needs to be answered is where and what am I? And that is answered by, first of all, the logging level itself. When you're logging, you should have multiple log levels, like, zero severity, like this is a debug message, this is an info, this is a notice, this is a warning, this is an error, critical error, the application is going down. Next, you should know what module the log is coming from. When you're logging and there's a message, where did this message come from? Instead of having to copy and search for that string throughout your application to figure out what module generated that log, you should also have an identification of what module generated that log, essentially what file.js, okay, or TypeScript, whatever you're using. And more specifically, if that module might be, more than 300 lines, what specific function generated that particular log? And finally, what time it is. That's important as well. Flags and tagging. I also mentioned that briefly before. This is what it is all about. So, when you're having an exception, an error, that is security related. So for instance, you have a user login and you have a failed login due to a wrong password. You should log that, and that should have the security flag turned on. Okay, so then you can easily query for those logs, and you could possibly add some automation when this happens multiple times based on a certain threshold, some business logic of yours. When the login succeeds, then this is an audit log. That user logged in, at that time from that IP address. Again, an IP is a PII. You should be careful about putting that on the logs, but I'm just trying to give you ideas as to what's important here. And then bogus is about bogus situations on your database. So that's the theory. Now let's dive into how Logality can help with that, with your logging. What is Logality? Logality is a versatile and extensible logger for Node.js. So we've finished with the theory of logging, what you should log, how, what, and all of that. Let's see now how we can do all of that and even more through Logality, and what Logality can do for you. Logality can naturally, log messages. That's its job. It can do that in JSON format, which is the native kind of way that Logality is logging, and we can also pretty print, which are human readable messages. You can extend the logging schema. So, JSON logging means that there is a schema, and you can also extend that schema, or you can even alter it so that it fits your needs. Logality supports serializers, and we're going to see in detail what that means and why this is important. And you can build your custom built serializers, or you can even customize the built-in serializers. Logality comes with a few serializers that are built into the library. And Logality supports middleware, which is very important for you to be able to intervene in the life cycle of a log message and add some business logic that, depending on the log, what is being logged, you can take some different action. And we're going to see again details and examples on how this works. Continuing on the features of Logality. So Logality allows you to fully manipulate the output or even mute it. And this is also important depending on the use case. We're going to examine a couple of use cases where this is going to be very useful. And Logality supports asynchronous operations, which basically is one of the best features of Logality that, if you keep one thing from today's meeting is that Logality is an asynchronous logger, which enables you all of the above, which I've already mentioned, which are, middleware. You can have an asynchronous middleware, which means that you can perform I/O. You can store on a database certain log messages that are important to you, or you can transmit them through a REST or any other means to a different server. And we're going to see many examples about that as well. The other very important feature of Logality, and it's again it's basically the first library that allows that, is that you can include logs in your library. So basically every NPM package that there is out there, there's a whole set of problems with having logging on libraries. Okay, so the libraries that you depend on Node.js, they cannot themselves have logs because they might not be compatible with the system that you're using. And they might, skip all of your certain methods and ways that you're logging and log directly on the STD out, but in a different format. And this is problematic. Logality solves that with a very eloquent way. And the last but not least feature of Logality is that it will automatically detect where it was invoked from and add it as part of the log message. So you don't need to mention in the log message, what file you were logged, the log came from. That will happen automatically from Logality for you. Now, this is an expanded JSON output of a typical Logality log message. We can see the log level expressed both as an integer and as a string. Both are important because as an integer, it will help you, order and compare which log message is more important than the other. And as a string, it will help you query for certain log level messages. For instance, I want to see all warn messages or error or all critical messages. A timestamp naturally in the ISO 86 format, the log message itself. And then it is the Logality's custom schema, which is broken out into either an event or the context. An event is when something happens, basically an error is an event. And the context is a set of metadata that follows, that Logality attaches based on the system information that it automatically detects. So for instance, the application name is test Logality. And this is where the log message was invoked from. That's the module. This is automatically detected and attached by Logality for you. And some certain, metadata regarding the process ID, the process name, the host name that will help you weed out certain cases when you're having multiple servers running the same application. This is going to be particularly useful in those cases. This is a pretty print output. This is how the log messages render depending on the log level. Logality uses the syslog severity levels. It's based on specific RFC. So we have debug, info, notice, warning, error, critical, alert, and emergency, following the Unix syslog severity levels RFC. Now let's talk a little bit about serializers. So what is a serializer? First of all, let's look into the syntax of a log message. So we have the log, which is the instance of logality. Then we have the method, which represents the severity, the log level. So you have info, you can have warn, debug, all the levels that we saw in the previous slide. What follows as the first argument is the message. So what happened? A user logged in. And the second argument is basically an object literal that accepts any key value pair. And there are certain keys that Logality has built-in serializers for. And basically, let me rephrase that. Every key that you use in the second argument requires a serializer in order to render it. And what does that mean? It means that the serializer is going to check for that key, and then it's going to properly serialize the value that has been provided for that key. So for instance, we have the user serializer, that is a built-in serializer, and you will enter your user data object, and Logality will automatically fetch an ID and email for that user. We have the built-in error serializer that is going to serialize the error message appropriately so that it logs nicely on your log message. So it will have the error, it will have the stack trace in a proper way. And this is very helpful as well. And one of the other built-in serializers is the express request object. So you can just enter the request object directly into Logality, and it will serialize it in a way that it will show you where the request came from, with what headers, and all very other helpful information for you to debug. You can also build your own custom serializers. So say that you're building, an e-commerce application, and you have the order data object, and that the order data object has a very specific schema. What happens is that, in a serializer, you define, okay, the order object has like 25 keys, but when I give you an order object, I only want you to log these 4 keys, and you define what those keys are, and then you define where the values are going to be found from the order object that you provide. So now I believe that you can realize, how powerful a serializer is and why it is important. So whenever throughout your application you log and you need to log, something that is related to an order, the only thing you have to do is set in the context the order key that will trigger the serializer that you define, and then provide the order item, which is your standard order object, data object. As I said, in the features, you can override the built-in serializer. So a built-in serializer for Logality is the user. You can override it, and you can define your own schema on what is going to be logged and how. And that's basically it. And then whenever you need to attach, this action happened by this user, or this user failed, etc., whatever, then you simply, in the context, mention the key, which is the user, that will trigger the serializer, and you provide the user data object, typically in an Express application with sessions that is in the rec.user space. Middleware support. That is a very important feature. Middleware are invoked after the serializers are done. And it's very straightforward. Basically, it is middleware as you know them in Express, only that you have a single argument, which is basically the context. And the context is the entire log message represented as a native JS object. So if you remember the JSON output that we saw before, that is exactly what the context is. And you can manipulate, you can mutate the log message itself. And this is the part where you can completely change the schema of what is going to be logged, remove keys, like in this case, we delete the entire user object, or transpose them and do whatever you want with that and add any kind of business logic that you want. We'll come back to middleware when we're going to talk about asynchronous, which is next slide actually. So when logality is asynchronous, and that is a configuration switch when you're instantiating logality, you declare that I want logality to be asynchronous, then your middleware is asynchronous. And as you can see here, the function, the callback for this middleware is an asynchronous function. And then you have an await, a DB write of the context. So essentially you can store specific log messages in different data stores. And that is critically important if you're doing a highly secure database or a quite complicated database. And if you remember, we mentioned, we talked about flagging and tagging log messages with booleans. So for instance, if you had the audit boolean enabled, you could have some business logic that would write in your immutable data store that specific message, okay? So this is very important and a very, this big difference between logality and other logging applications out there. Now, of course, for this to work, when logality is in asynchronous mode, that means that every log message needs to happen asynchronously. So basically the log.info function returns a promise, and that promise needs to be handled. And everything that follows, handling of a promise. In this case, we have an await that should be wrapped in a try catch, possibly if you're doing some complicated stuff here, or you should kind of make sure that within your asynchronous middleware, you handle all of your errors. So, that doesn't break out from unexpected places. And the final, the final function before output happens can be configured in the configuration of logality. So this is how a logality is configured and instantiated. You have the app name, which is basically what this application is called, whether you have a preprint, whether it's asynchronous. And you also have the output, which is the master output function that manages how this is going to be handled. And you can handle the output yourselves. And if you don't return anything from that callback, logality will not do anything. So essentially, you are redirecting and have complete control over what is printed or how a log is handled through the output callback. And I mentioned that logality can be used in libraries. And the way this happens is that from your library, you now expose logality, and upstream, the consumer, the main application that is using your library, the only thing that it has to do is use the pipe method. And this is the third-party library. The third-party library exposes a logality instance, and you take that instance and you pipe it into your logality instance. This is the main application, and that way now you have full control of and the homogeneous logging from your third-party libraries into your own application. This is important if you're writing open source libraries or other kind of libraries that are being included by your application. So that was logality. Let's have a look at what other logging libraries are in the market. And we're going to see how logality compares with them. So we have Winston. It's the most popular logging library, which I've never used. I don't know. I can't say much about it. Node.js is the fastest library out there. and it has been optimized by some very smart folks that are also Node.js core contributors. And that is what Pinot does best. It is the fastest logging library out there. Bunyan used to be the go-to library a couple of years ago, but at this point, I believe it has been a little bit surpassed feature-wise, and it's a little bit more hard to work with in terms of changing the schemas, etc. But let's see in detail what this means. So we have a comparison chart here. So JSON output, all four libraries do that. Pretty print, Bunyan doesn't do that out of the box. You're going to need to install a third-party library to do pretty print with Bunyan. Custom log levels, Winston and Pinot do custom log levels. So remember, Logality has the syslog RFC that cannot be changed. Serializers, we talked about serializers, what they are and why they're important. Winston does not do serializers. Excuse me. Middleware, we talked about how middleware are powerful. Bunyan doesn't do middleware, and the reality is that both Winston and Pinot don't have a very straightforward way of doing middleware, but there are ways that you can actually use the libraries through other means to emulate a middleware behavior, although they are synchronous. Mutating the JSON schema, you cannot do that on Bunyan or Pinot. You are married to that schema. You can alter the schema of Winston, albeit in a very, very complicated way. And with Logality, you saw how easy it is through the middleware and the master output function. Output destination, you can define multiple output destinations, so different output destinations on all libraries. Mutating the output, we saw the master output function on Logality. Winston also supports it, again, albeit in a very complicated way. Asynchronous operation, Logality is the only library that does that, and we explained why this is important. File name detection, automatically detecting what module the log came from, can all be done by Logality. Speed optimized, this is Pinot territory, clearly. If you care about speed, then Pinot is your thing. And use in library, Logality is the only library that can be used in third-party libraries. So if you are, again, an open source contributor writing libraries, you should seriously consider using Logality. So to recap, logging is important for debugging and troubleshooting, security and audit, performance monitoring. Appropriate logs at the right place can make all the difference with the right kind of information. And as we've seen, there are many loggers, and these are just the top loggers out there. I'm sure that there are as many lesser known ones. Choose the right one for your use case. That's the whole idea. Thank you very much. That was all. You can find this presentation on speakerdeck.com/fanpolas, my handle. And typically now we would have questions, but I don't believe there's anyone in the Zoom chat right now to make any question. So we'll just skip that.
Wait a second. Yeah. There is people on YouTube, so there are 11 people watching at the moment.
Okay, so, is there a chat? So can you relay the question for me? If anybody wants to ask something. I believe there's also a lag, so.
I think what happened, actually, it's good to use Logality because you know where your talk ended before the big mess happened.
Yeah, I mean, that's a very good. This is something that I used to do before Logality manually. Essentially, on the log message, I would start by, okay, this is the module that is producing the log message, and dash function. So I had, basically made a convention on how logs should happen, starting with these prefixes. And naturally, this is inconvenient. And in a team, somebody's not going to follow that. So you're going to have some log messages that say, this happened, and you don't know where this log message came from. And that's why I considered that automatically detecting the module that the log came from is a critical feature for a logger.
There is a question, and it's from K. Fassman. Isn't it risky to add an asynchronous call inside a logging? I think he missed that. That's why I was trying to.
Yes, it is risky. It is very risky because a lot of things can go wrong. And let me find the right slide for that.
The continuation, while you're looking for it, and K, I don't know what K stands for. He says that to me, it looks like login should be a risk to crash.
Yes, that is correct. So when you're doing a database write through the logging lifecycle, that is a very risky operation, right? A lot of things can go wrong here. The database might not be available. What you're writing, the schema of what you are writing to the database might not be compatible and produce an error. A lot of things can go wrong. And that is why you need to be very careful and you need to be very conscious about using the asynchronous function in this case. The reality of it is that the alternative for that would be, so for instance, let's say audit logging, okay? And you want to have an audit log of what happened and when, by whom. Let's use the login example, somebody logged in. And you want to have an audit log of that. So you can do that as a one-liner on the function that is logging user in, or you can have it as 2 lines. The second line being, save the login to the audit log store. It's a personal preference in a way. I would prefer that I would have a single line, and I would prefer that I decouple this logic down into a middleware through my logger, because at this point now the logger has become, an event bus in a sense. And by creating a middleware that is filtering for the audit Boolean tag, is what I'm talking about. And as I've already mentioned, you should be very conscious about handling all the errors that might be produced in a logging middleware, or there is the risk of entering into an infinite loop, right? Because if you generate an error in the middleware and it's not caught, it's going to be caught on the master error handler of Node.js, where you also have a log, and this might enter the application in an infinite loop. So definitely be conscious about what you're doing. And yes, it is very risky, but also at the same time, it provides this convenience and feature. This is quite an advanced feature, and you should be conscious about using it.
He also says that he's apologizing that his question was not formulated very well. He says that he saw an await DB write function call inside a logging function, if he's correct.
Yeah, that's exactly the slide that I have right now.
Mm-hmm.
So, you essentially, when you enable asynchronous mode on Logality, you have to, it's not obligatory if you know confidently that you don't have any asynchronous middleware for that specific log. But as a good practice, if you enable asynchronous on Logality, all of your log messages should be handled asynchronously, which means, prefix them with an await. And again, this is a very simplistic example, but what you should expect here is, let me see, can I annotate text. All right, so I would, the typical example that would make sense is to have, a user logged in. And then in the context, you have, what user logged in. So rec.user. And then you're going to have an audit.true tag. Okay. And in this particular case, can I make this larger? Not sure, probably not. So in this particular case, what I'm doing is that then in the middleware, I'm going to have a conditional that checks only for audit true log messages, discards everything else. If it's not the audit, if it's not true, then move on to the next middleware or move on to the master output. But if the audit is true, I need to write this log message into my immutable data store, because this is important information for my security-aware application. And that was the use case. That was exactly the use case why I introduced asynchronicity in the log message. And that's exactly the use case how I use asynchronicity in a production application, where I need to store audit logs into different data store other than the data store that all of the logs end up.
Any sense? Let's see. Before we, so you did have some questions. That's really good. Do you know any good use cases, like other than your own, that they're using these kind of tools and big companies that use these systems?
No, I do not. This Logality is a fairly new library, and a library that I haven't really spent much time, marketing. Let's call it. And this is my first ever presentation about the library. It does have 100 stars, and I believe some users are using it on their personal projects. I'm not aware whether this is used on production. I cannot tell that. I haven't been informed about it. I would really be happy to hear about that if somebody does that, and probably ask for an advice or how the right patterns about it. In the Logality repository, you can find another application that is open source, which is a Discord bot that uses Logality, so you can see how Logality is used in a real life application.
Okay, that's good. Thank you, Thanasi. As you know, Thanasi is one of the persons that helped me start at CityJS, so I know him quite a lot.
Come on.
Okay.
Right. Thank you very much, everybody. That's all from me.